Hey everybody, it's Sonic here. This is screencast number 1 entitled Solids, Liquids, and Gases. We will include a little bit of phase change information as well. This particular screencast is for both honors and grade level. The content covered within this video will be quizzable on this week's homework quiz, and as a requirement for this week, you are expected to take notes on this, and those notes are due Thursday during class. So let's talk a little bit about solids, liquids, and gases. First diagram is not that one. That's the diagram I want to give you. Simplest way to look at this, ladies and gentlemen, is water. Water can be found in the form of a solid, and that solid is ice that we know. H2O is a pure substance. It's got its own properties, so it's got a freezing temperature of 0 degrees Celsius. If you heat that up, that solid, eventually it's going to hit the point at which the particles bounce around enough, they jiggle enough that these particles right here will break apart and they will fall over each other, and when they slide past one another, the bonds have been broken. We call that a liquid water. The state of H2O at room temperature. If we continue to heat that up, if you can see this temperature gauge on the right-hand side, if we continue to heat that up, those particles will move harder and faster, even more and more and more, until they completely break free and they become gas particles. No longer are they sliding over one another, but instead they are free to move in any direction. So what you have here, and this is the important point to remember, and I would definitely write this down. It is in your foldable, but by all means make sure that you have this concept down. A solid has a fixed volume. That means a volume that is unchanged or remains unchanged no matter what you do to it without adding heat energy. If we move it around, if we push on it, it's going to keep its volume. A liquid also has a fixed volume. It doesn't matter if I pour it into a graduated cylinder, a beaker, a coffee cup, or throw it on the floor, it is going to have a fixed volume. A gas, on the other hand, spreads out. It will fill the container it's in, so a gas does not have a fixed volume. Solid and liquid, fixed volume. Gas does not have a fixed volume. As far as its shape goes, a solid will keep its shape. A liquid will take the shape of the container it is in, and a gas will also take the shape of the container it's in. The difference between a gas and a liquid is a liquid will settle at the bottom, a gas will not. A gas will fill a small box, it'll fill the size of a classroom, it spreads out to all available areas. Now if we jump to a little diagram here, you can see we have a diagram of the particle arrangement. The arrangement of the particles is worded regular or random. And then the movement. Either there's vibrating, moving around each other, or moving quickly. Solid, liquid, and gas. And then the closeness of the particles is referred to here. Very close, close, and very, very far apart. In class, we talked a lot about this stuff, this sonic slime. And you can see it has taken the shape of the counter that it was lying on. Over time, this will turn into whatever shape it's allowed to turn into because it's slime. It's got a lot of the qualities of a liquid. In fact, part of your homework tonight is to determine, is this a solid, a liquid, or a gas? It behaves like a liquid. The particles appear to move over one another. There's a certain flowing aspect to it. It holds its volume, but it doesn't hold its shape. But on the other hand, you can break it apart like a solid. This sort of shearing aspect of it is definitely unique. Oobleck, cornstarch and water, shaving cream, Jell-O. What are these? Are these solids, liquids, and gases? And when you consider them, put them in the context of particle arrangement, movement, volume, and shape. One more diagram I want to show you. There's four or five. What is it? 1, 2, 3, 4, 5 different descriptions of how states or excuse me, substances, how they change their state. We call them phase changing. So the one that we haven't talked a lot about is this concept of sublimation. We will be discussing this further next week when we introduce some dry ice. Dry ice is frozen carbon dioxide. It can be harnessed as a solid, or it can be harnessed as a gas. But there is no liquid stage to it. It skips the melting stage. It goes from a solid to a gas. And a gas to a solid, that skipping we call sublimation. When a gas turns to a liquid, typically by cooling it, we call that condensing. When we experience condensation on the grass on a spring or even a summer morning, it's because the temperature got cooler overnight and the moisture in the air condensed on the grass, much like the side of a Coke can, a cold beverage on an aluminum can. Now, on the other hand, a liquid, if we add enough energy to it, will eventually boil and turn to a gas. That same liquid, if we take temperature away from it, heat energy away from it, it will freeze into a solid. That same solid, if we add heat energy, will change to a liquid, and we call that melting. So notice that these arrows are very distinctly colored as blue and red to indicate the loss or the gain of heat energy. So again, this content is important for the quiz on Friday. I hope you took notes. Feel free to rewind, watch me again, pause it, but this information is critical for the quiz and you need to have it. All right? Good job making it